Understanding code requirements is crucial for safe electrical installations, particularly when dealing with underground cables carrying signals. To locate the specific code sections that govern these installations, it's important to consider several factors. Firstly, identify the type of cable and the voltage level involved. Cable companies often utilize cables carrying signals at 90 volts or less. The National Electrical Code, or NEC, is the primary resource for electrical safety standards. The NEC addresses underground wiring in Article 300. Specifically, Section 300.5 details the requirements for underground installations, including minimum burial depths and protection methods. These depths vary based on voltage and the type of wiring method. For example, direct buried cables operating at 600 volts or less typically require a minimum burial depth of 24 inches. However, this depth can be reduced to 12 inches under certain conditions, such as when the cable is encased in concrete or is installed under a 2-inch thick concrete pad. For residential branch circuits rated 120 volts or less with GFCI protection, a minimum burial depth can be reduced to 12 inches. It's essential to consult Table 300.5 to determine the specific burial depth requirements for different wiring methods and voltage levels. Secondly, consider the location of the cable. If the cable is installed under a building or other structure, additional requirements may apply. Section 300.5c addresses these situations, specifying that the cable must be extended beyond the structure. The code also addresses the need for protection against physical damage. Cables installed in areas subject to vehicular traffic must be protected by conduit or other approved means. Section 300.5d covers protection from damage. When dealing with cables buried less than the required depth, additional protection is necessary. This may involve encasing the cable in conduit or providing a warning ribbon above the cable to alert excavators. Thirdly, grounding is a critical aspect of electrical safety. Improper grounding can lead to dangerous voltage on cable lines. The NEC provides detailed requirements for grounding and bonding in Article 250. Section 250.32 specifically addresses grounding requirements for separate buildings or structures. The cable shield or metallic sheath must be properly grounded to ensure that any fault current can safely return to the source. This grounding helps to minimize the risk of electric shock and equipment damage. Also, Section 250.4 covers general requirements for grounding, including the need to establish an effective ground fault current path. This path ensures that ground fault protective devices, such as circuit breakers and fuses, can quickly clear any faults. Fourthly, consider the local amendments to the NEC. Many jurisdictions adopt the NEC with local amendments that may modify or add to the requirements. These amendments are often based on local conditions or concerns. It's essential to consult the local electrical code to determine if any additional requirements apply to underground cable installations. For instance, some localities may require additional inspections or permits for underground wiring. Fifthly, cable companies may have their own internal standards and practices that go beyond the minimum requirements of the NEC. These standards may address specific issues related to their equipment and operations. It's important to communicate with the cable company to understand their requirements and ensure that the installation complies with all applicable standards. Furthermore, Section 820.100 of the NEC covers grounding of coaxial cables. This section requires that the cable shield be grounded as close as practicable to the point of entrance to the building. The grounding conductor must be sized in accordance with Section 820.100d and must be connected to the building's grounding electrode system. Additionally, Section 820.110 addresses bonding requirements for coaxial cables. This section requires that the cable shield be bonded to the metal water piping system, the grounding electrode conductor, or other available grounding means. Bonding helps to minimize voltage differences between the cable shield and other metal parts, reducing the risk of electric shock. It's also important to consider the type of soil in which the cable is buried. Corrosive soils can damage the cable and its grounding system. If the soil is known to be corrosive, additional protection measures may be necessary, such as using corrosion-resistant cable or encasing the cable in a protective sleeve. In addition to the NEC, other standards and guidelines may apply to underground cable installations. For example, the National Electrical Safety Code, or NESC, provides guidelines for the installation and maintenance of overhead and underground power and communication lines. The NESC addresses issues such as clearance requirements, grounding, and protection from physical damage. To locate the specific code sections that apply to a particular installation, it's helpful to use the NEC Index and Table of Contents. These resources provide a comprehensive overview of the code and can help you quickly find the relevant sections. You can also use online search tools to search for specific keyword or phrases within the NEC. When in doubt, consult with a qualified electrical inspector or engineer. These professionals can provide expert guidance on code requirements and help ensure that the installation complies with all applicable standards. It's also important to keep in mind that the NEC is updated every 3 years. The latest edition of the NEC should always be consulted to ensure compliance with the most current requirements. Changes to the NEC can affect burial depths, grounding requirements, and other aspects of underground cable installations. Therefore, it's essential to stay up to date on the latest code changes. When installing underground cables, it's important to follow all manufacturers' instructions and recommendations. The manufacturer's instructions may provide additional guidance on installation procedures, grounding requirements, and other important considerations. Failure to follow the manufacturer's instructions can void the warranty and may result in unsafe conditions. Before beginning any underground cable installation, it's important to obtain all necessary permits and approvals. Many jurisdictions require permits for electrical work, including underground wiring. Obtaining the necessary permits ensures that the installation will be inspected and approved by qualified professionals. This helps to ensure that the installation complies with all applicable codes and standards. In addition to the NEC and other codes and standards, it's also important to consider best practices for underground cable installations. These practices can help to improve the reliability and safety of the installation. For example, it's important to use high-quality materials and components that are designed for underground use. It's also important to properly compact the soil around the cable to prevent settling and damage. Furthermore, it's important to provide adequate drainage to prevent water from accumulating around the cable. Water can damage the cable and its grounding system, leading to corrosion and other problems. When installing underground cables, it's important to take precautions to protect workers from electrical hazards. Workers should wear appropriate personal protective equipment, such as rubber gloves and safety glasses. They should also be trained in safe work practices and procedures. It's also important to de-energize the cable before working on it, if possible. If the cable cannot be de-energized, workers should use insulated tools and equipment to prevent electrical shock. In addition to electrical hazards, workers should also be aware of other potential hazards, such as underground utilities. Before digging, it's important to call the local one-call center to locate any underground utilities in the area. This helps to prevent damage to the utilities and injuries to workers. In summary, locating the specific code sections that govern underground cable installations requires a thorough understanding of the NEC and other applicable codes and standards. It's important to consider the type of cable, the voltage level, the location of the cable, and other factors when determining the applicable requirements. When in doubt, consult with a qualified electrical inspector or engineer. They can provide expert guidance on code requirements and help ensure that the installation complies with all applicable standards. Remember to always prioritize safety when working with electricity. Follow all applicable codes and standards, and use safe work practices and procedures. By taking these precautions, you can help to prevent electrical accidents and injuries. Also remember that 90 volts while being low is still able to cause harm, and there have been many deaths at voltages lower than this. Always treat every source of electricity with respect. Firstly, identify the type of cable and the voltage level involved. Secondly, consider the location of the cable. Thirdly, grounding is a critical aspect of electrical safety. Fourthly, consider the local amendments to the NEC. Fifthly, cable companies may have their own internal standards and practices that go beyond the minimum requirements of the NEC.